Welcome to homework.
Hello everyone, today we're doing chapter 14, problem 28, and this problem gives us the structure of this molecule and it asks us to determine the number of carbon-13 NMR peaks you will see on its C13 NMR spectra. So what we need to do is, just like in proton NMRs, is identify the number of chemically distinct carbons in this molecule. So number of chemically distinct, unique carbons that exist in their own unique microenvironment on this molecule. So we see that there's no internal plane of symmetry. So that means that every single carbon here must be chemically distinct. But let's confirm that. So we have this carbon here, you can say it's C1, that cis to this group here and is bound to a carbonyl carbon. But what about this carbon here? So this is also a terminal methyl carbon. But this terminal methyl carbon this time is now cis to this hydrogen and is trans to that big group here. So this is obviously going to be in a chemically unique environment than C1, so we know that's C2. Well, what about this alkene carbon here? Well, this alkene carbon is bound to two methyl carbons and one group here. So this is different from any other carbons that we investigated here. So it's going to be C3. And what about the other alkene carbon here? So this alkene carbon is bound to a hydrogen and this big group here. So this is also going to be a unique carbon. So C4. And now what about this cyclopropyl group here? Well, this cyclopropyl group is directly bounded to an alkane, hydrogen, a carbon. So this is unique to compare to anything else we've seen before. So this is also C5. And what about the other side? Well, the other side is now bound to hydrogen, two carbons, and an ester group. So that's also going to be unique. C6. Using the same logic, we can see that this carbon is also going to be unique. C7. And these two will be unique because there's going to be some stereochemistry around these carbons here. And they're going to be, one is going to be closer to this carboxylic acid, while one will be further away. So we know that we have a C8 and C9 carbons. We have 9 different carbons. We'll have 9 signals or 9 peaks in our C13 carbon NMR